Welcome back to another video. In this tutorial, we are going to dive into the concept of this trig identity, all right? So we know that 1 plus tan squared theta is equal to sec squared theta, right? So from here, we know that the trig identities or the trig ratios are defined based on the size of the right angle triangle, right? So here, let's try to draw this figure. So this figure here, we have 90 degrees here, we have an angle here, right? So this now becomes a right angle triangle. So we label here A, B, and C. Okay, so let's try to name this distance ABC, okay? Right, so the longest part is the hypotenuse, right? And that is this one. And this part is the opposite, right? And this is the adjacent, right? So we have this diagram, right? So you know that from Pythagoras theorem, from Pythagoras theorem, from Pythagoras theorem, if you want to find the one side of a right angle triangle, then you're going to say that the longest, the square of the longest side, which is c squared, equals square of each of the two sides, sum of the square of each of the two sides. So a squared plus b squared, right? So we have this information. Let's get it down. Now we know that there is something called SOHCAHTOA. SOHCAHTOA. Where this so is the sine of a particular angle equals opposite over hypotenuse, and K is cosine of a particular angle equals adjacent over hypotenuse, and TOA is tan of a particular angle equals opposite over adjacent. So in here, we are interested in the TOA, which is tan, right? So we're going to have tan theta or tangent theta equals opposite over adjacent, right? And opposite from this illustration is A, right? So we have tan theta equals A over adjacent, which is B, right? So we have this information. That is great. Now, we know that this right here, okay, let's try to obtain the sine as well. So from the diagram, we know that sine theta will be equal to opposite over hypotenuse, and that is C. Okay, and as well, we know that K, which is cos theta equals adjacent, which is B. So we have B over hypotenuse, which is C, right? So we have these informations. Now, from this information from Pythagoras theorem, you can see that C is equal to square root of A squared plus B squared, right? So we substitute that here, we're going to have A over square root of A squared plus B squared. The same thing that applies to the cos theta, right? So we're going to have B over square root of A squared plus B squared. That is great. So we have these informations. Let's try to make E the subject in sine theta and make B the subject in cos theta, right? So let's name this equation 1 and this equation 2. Okay, so from 1, we are making A the subject. So that is going to be A equals sine theta times square root of A squared plus B squared. right? So we have this information. Let's come to equation 2. Equation 2, making B the subject, we're going to have from 2, making B the subject, we're going to have B equals cos theta times square root of A squared plus B squared. That is great. So we have A equals sine theta times square root of A squared plus B squared, and cos theta, and B equals cos theta times A square root of A squared plus B squared. Okay, so we have no doubt, we have no chance than to do substitution in here. So let's say that this is 3 and this is 4, right? So let's consider this as star, right? So this star here, we have it in terms of A and B, right? So we substitute A from here, whatever we have here, we substitute, and B, whatever we have, we substitute, so that we can have an expression for tan. So we're going to have sin theta equals A from here is sin theta times square root of A squared plus B squared all over B, where our B is cos theta times square root of A squared plus B squared. Wow. And that is what we are interested in. So we can see that this cancels this, and then we are having sin theta equals sin theta over cos theta, right? So we have sin theta equals sin theta over cos theta, right? Now, let's get into the game. So we know that sin theta is equal to sin theta over cos theta, right? So we come here into the given equation, we consider the left-hand side to prove the right-hand side, right? In every proof, you either use the right-hand side to prove the left-hand side, right? So over here, we are using the left-hand side to prove the right-hand side. Good. So let's get into it. So over here, we're going to substitute this in place of that. So we're going to have 1 plus sine squared theta, sine theta over cos theta, right? But the tan is squared. So we're going to square all this, okay? And that should be equal to sine squared theta, sec squared theta over here. Good. So we have 1 plus sine squared theta over cos squared theta. And that should be equal to sec squared theta. Okay. So this we have right here, you know that this is over 1, right? So when you find the LCM for this, you're going to have cos squared theta. Okay. So this goes here, and then it multiplies 1, and we have cos squared theta. This goes here, cancel out, right? And leaving plus sine squared theta. And that should be equal to sec squared theta. But we know that in my previous video, I proved sine squared theta plus cos squared theta to be equal to 1. So we substitute that identity in place of this. And that will be giving us 1 over cos squared theta equals sec squared theta. That is great. So briskly, we're going to have 1 over cos squared theta, right? And that is equal to sec squared theta. This is an identity. So briskly, we have used the left-hand side to prove the right-hand side. That is the process. So note this as well. So note that sec square theta is equal to 1 over cos squared theta. This is also a minor identity that you have to know. So once you have 1 over cos squared theta, don't be thinking too much. That is basically sec squared theta. And that is the proof. So therefore, or hence proved as required. Hence proved as required. Okay, so I want to give you a little bit tip in here. A little bit tip in here. You know that there is one identity that cos square theta minus sec sine square theta is equal to 1. Uh, is equal to 1 minus 2 sine squared theta, right? So this is obtained from sine squared theta plus cos squared theta. So from here, we say that okay, cos squared theta plus sine squared theta is equal to 1. Okay, so this basically is going to give us, if we try to make sine squared theta the subject, then we're going to have sine squared theta equals 1 minus cos squared theta. Okay, so this is basically telling us that wherever we see sine squared theta, we put 1 minus cos squared theta. Okay, but we want to do this, we want to have this. So let's make cos squared theta the subject. So we're going to have 1 minus sine squared theta. Okay, so we substitute this. Okay, we substitute this into that. Okay, so let's do that and see what we're going to have. So we substitute that, and we're going to have 1 minus sine squared theta minus wherever we see okay, so cos squared theta is 1 minus sine squared theta minus sine squared theta minus sine squared theta, and that should be giving us 1 minus 2 sine squared theta, because we have minus sine squared theta minus sine squared theta, and that becomes negative sine squared theta. So we have 1 minus 2 sine squared theta, and that is equal to that. Okay, so this is also an identity, and when you try to substitute this also into this, then you're going to have cos squared theta minus sine squared theta is equal to 1 minus sine is equal to, okay, so let's try to substitute sine squared theta into this. So we're going to have cos squared theta minus into 1 minus cos squared theta. Okay, then we're going to have cos squared theta minus 1 plus cos squared theta. Okay, so this is basically going to give us 2 cos squared theta minus 1. Okay, so basically, we can also say that cos squared theta minus sine squared theta is equal to cos 2 cos squared theta minus 1. Okay, so That is that is that is cos square theta minus sine square theta is also equal to 2 cos square theta minus 1. Or this is the same as cos square theta minus sine square theta is equal to 1 minus 2 sine square theta. So this is an identity and this is also an identity. Okay, so please don't mess up with um, the where we have the positive. Don't mess it up. This is an identity. This is also an identity. Okay, so that is the process. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mate, and I'm going to give you more updates. Bye bye.